In this video, we'll take a look at one of the larger portable power stations on the market, the Campower 2000 by AceVolt. The Campower 2000 is a 1,997 watt-hour power station in a surprisingly small form factor. On paper it looks really good. I won't read off the full spec sheet, but some highlights that jump off the page are: it promises the fastest charging speeds that I've seen for a unit in this size range at 1.5 hours. It has a UPS function, and it has one of the highest outputs that you'll find on its USB-C output at a full 100 watts. It uses the longer lasting and more stable lithium iron phosphate battery cells inside, so it makes a much better long-term investment than competitors that use other battery chemistries. The rest of the specs look pretty comparable to the competition, and you can find them at the link in the video description below. Inside the box is a user manual, an MC4 cable for solar charging, and an AC charging cable. You may notice that there's no power brick or AC adapter. That's because it's built into the power station. So not only do you not have to deal with a big, heavy, awkward adapter, but the AC cable is interchangeable with any PC power cable. So the fact that the adapter is built in and it uses the slightly bigger and heavier LFP cells makes it surprising that the Campower 2000 is so compact. At only 43 pounds and 15 by 11 by 12 inches, it's among the smallest power stations on the market for this amount of power and capacity. Also of note here is that the case feels very sturdy. It has metal handles and feels very rugged and solid, and not at all plasticky and cheap. But there are some other things that do seem cheap. So let's get the bad and ugly things out of the way. First, the manual's in Chinese, with an English section in the middle. It's also missing any contact information or detailed warranty and support information. All of this information is available on their website, but it should still be documented in the manual, and an English-only version should be included for American customers. The circuit breaker on the side is a cheap, off-the-shelf part that looks like something from Radio Shack. And the door flaps that protect the AC outlets and the charging ports on the side from dust and moisture are very flimsy and are guaranteed to break if this thing is used outdoors or in rugged conditions very long, or around kids. I'm sure it works fine, but a power station costing well over $1,000 should have stronger door flaps and buttons than that. So while I'm very impressed with its size and weight and some of the specs, there are some things that need improvement if AceVolt is going to try to challenge EcoFlow, Jackery, and Blue Eddy. Let's see how it performs in our battery of tests. But first, we need to charge it up. We'll talk about the charging a bit later, but they aren't lying about the supercharging ability of the Campower 2000. It ramps up to a full 1100 watts of AC input and is charged in no time. And you can also add in another 500 watts of solar input at the same time for a total of 1600 watts of charging power if you really wanted to. With the Campower 2000 fully charged, we'll hook it up to our power station test rig for a low power test. If you haven't seen it before, this test rig takes a 120 volt AC feed from a power station and distributes it through a load center to 4 light sockets that I can swap out with different bulbs to achieve almost any load value I want. For this test, we'll use a single 250 watt heat lamp bulb and let it run until the power station shuts off. As you can see, the light bulb is not drawing its full 250 watts, which means that the Campower 2000 is not producing a full 120 volts. I measured the output with my power meter at 111 volts. That's within the acceptable range for almost all devices. They'll just draw slightly more current, so it isn't a big deal, but some resistive loads like incandescent lights will not operate at their peak. The power station lasted 7.57 hours and produced a total of 1,627 watt-hours. So it didn't quite make it to my expectation of 8 hours, but it is 100 degrees outside, so the heat definitely affected it also. So back inside we will recharge it and get ready to go again. While it's charging, we'll try to test AceVolt's claim that it can charge to 80% in just 87 minutes. Unfortunately, the test got interrupted because I tripped a breaker in my home. And while that may be frustrating, it does show you how powerful that charger is. To feed the Campower 2000 with 1100 watts of AC input, it draws almost 1200 watts of power from the wall. And most home AC circuits in the US are 15 amps, which is 1800 watts. So if you have other devices on the same circuit like I did, you may trip a breaker. So keep that in mind. That isn't the Campower's fault, it's just the price you pay for charging really, really fast. Anyways, after fully recharging, we will begin the next test. This time, we're going to get a lot closer to the Campower's 2000 watt max continuous output. We're going to power a few heat lamps and a space heater on its highest setting. Once again, we'll let them run until the power station shuts off. This time, the Campower lasted 0.93 hours and produced 1,628 watt-hours of power, almost exactly the same as the previous test. Now let's try again to test the AceVolt claim of recharging to 80% in 87 minutes. I'm using a circuit this time that I'm quite sure can handle the whole test. I accidentally set my alarm for 84 minutes instead of 87, where the Campower was 72% recharged, so another 3 minutes would have gotten it pretty close to 80%. And it does get to 100% full in under 2 hours. With the Campower recharged yet again, let's do a couple final tests. First, let's see how it does against one of the biggest power hogs around, an air conditioner. Because I know some of you out there will try to power your RV air conditioner with this. Don't act like you aren't going to try. It took a while for the compressor to kick on and reach full power. As you can see, it levels off around 800 watts, which isn't crazy, but when that compressor turns on, it pulls a huge amount of power for a split second, and many other power stations have failed to handle that. This is a 10,000 BTU air conditioner if you're curious, and it ran for 2.08 hours. The power draw varied a bit, but again, the Campower produced over 1,600 watt-hours. And finally, let's go well above the 2,000 watt rated output and see what happens. I grabbed a vacuum to add to the same loads as the second test. So we went well above 2400 watts and stayed there for over 10 seconds, and there was no complaint at all from the Campower. Not bad at all. Some of you may be wondering about us only getting 1625 or so watt hours in the tests. I don't like it, but most brands just report the raw power capacity of the battery cells inside and not the actual power you're going to see from the inverter output. You would get the full 2,000 watt hours from DC outputs, but for AC, a 20% loss through the inverter is pretty common. The Campower is middle of the pack in terms of the AC output in watt hours, but I was impressed with how fast it charges and how well it handled the torture test. It can run an air conditioner without blinking and go well above its rated output for more than just a split second. In conclusion, AceVolt is a brand to keep your eye on, and the Campower 2000 is a solid competitor in the 2,000 watt-hour size class of power station. After I gave them my feedback, they promised me that a full English manual will be coming soon. If you're interested in purchasing this unit, you won't find it on Amazon. Use the link in the video description to go straight to the AceVolt website where there's currently a $200 off coupon. Thanks for watching this review video. If you liked it and found it helpful, give me a thumbs up and leave a comment below.